Here's the bell work. 2 problems. Give you guys a minute. Try these 2 out, okay? 1 minute, go. All right, there's our answers for those 2. Number 1 has 2 answers. Number 2 has no solutions because you can't have an absolute value that equals a negative after you've worked that out with some principles of equality. Well, there's our objective. I can solve problems with percents. And remember, even though we are starting a new semester, everything is still the same this year. Everything's on Canvas, all the assignments, quizzes, and tests. Well, the tests are on Master Connect, but the worksheets will be there for us just like usual. Everything's pretty much like usual, okay? It's just now it's a new year, 2021. All right, what is a percent? The word percent comes from the Latin word phrase of 100, or from the French pour cent. And yeah, I may have pronounced that wrong, but whatever. The percent sign was developed during the Middle Ages with the rise of banking. It comes from the shorthand of the Italian per cento. I don't know how important that stuff is, but whatever. One thing I like to notice is in other countries, it's actually written as 2 different words, right? Percent, which would mean that it's out of 100. Cent is 100 right there. So, you got like 100, right? The 2 zeros. And the percent sign is really just a 1 with 2 zeros around it like this. Per 100, okay? So number 2, shade 6 of the small squares in the rectangle below. All right. That's going to be hard, but I think we can do it. There's 1, 2, 3, 4, 5, and 6. Now, I did those randomly on purpose because generally it really upsets students. It's like, well, why don't you just put them in a row? Because it upsets you, okay? Did I count that right? That's 6, right? Yeah, okay. Not really to upset you guys. I just like to do it randomly. I know some of you guys are like, yeah, we did it randomly. Others of you guys, I know it disgusts you, though, okay? Because other classes have told me that they felt disgusted. I think one student started dry heaving before, but that's a whole different story. So it doesn't matter which 6 you shade in, though. It didn't say which 6 to shade. You just needed to say shade 6 in, right? So number 3, figure out what percent of the rectangle is shaded. You may not write an equation and solve it. That sounds weird. You must use the picture or a new picture to find the percent and explain how you figured it out. Okay, well, we don't really need a percent to solve this one. Well, here's what we know, okay? Because I would probably write this as a fraction first, right? And how many squares did we just shade? 6. And if I was able to stay in the lines, we'd know it's for sure 6, but hopefully you guys can stay in the lines better than I did. And then the next thing we would need to know is how many boxes there are. Well, this is a 4 by, what is that, 3, 6, 9, 10? 4 by 10 box, so it's 6 out of 40 of these, right? And we could even simplify this fraction if we wanted to further. I'd say, well, divide this by 2 and divide this by 2, which would then be 3/20. Now, does this help us to figure out what percent it is? Maybe, maybe not. Some of you guys are like, yeah, it does. Others of you guys are like, nope, it does not. That's fair. I mean, I guess both are kind of true. Here's what I mean by that, okay? Well, percent is out of 100. So could I possibly make this 3 out of 20 out of 100 slightly easily? And the answer to that is yes, we could. Just multiply we're scaling these fractions, right? So it's not like I'm changing the value of the fraction. I'm just changing the way it looks, specifically with the denominator 100. So I would just multiply the 20 by 5 to get 100. But if I do it to the denominator, in order to not change the value of the fraction, I must do it to the numerator as well. So I'd multiply the 3 by 5 and get 15 right there. Now this fraction, 15 hundredths, is really a percent, 15%. And that would be the percent right up in here, okay? Now it says you must use the picture or a new picture to find the percent and explain how you figured it out. All right, well, I feel compelled to, even though I don't really like that they're forcing us to do it. So here's what I would do. What did we do just before, right? I divided by 2. So I would say, I'm going to take this whole thing and I'm going to cut it in half. Okay, so now it's a 4 by 20, right? So I'm really just ignoring all this garbage over here. Okay, and how many are shaded? Well, 3 out of 20 now are shaded, right? Because it's a 4 by 5. There's a 4 by 5 rectangle. Well, that's 20 squares. Well, how do I make this so that it's 100 squares? Well, I'd have to multiply this by 5. Just up there. It is difficult to compare fractions when they have different denominators. When we turn a fraction into a percent, the comparison is easier because percents all have common denominator 100. That's true. For example, you would have to do additional arithmetic to decide if 640 is greater or less than or equal to 68 4/60. But it is easy to see that 15% is greater than 14.8%. Yeah, hopefully that seems easy. Complete the table to review changing fractions and decimals to percents. Okay. Well, here's what I would do to change a fraction to a decimal. And this is going to be, well, it may seem more difficult than it needs to be, actually. So, as a fraction, right, 98/86. Okay. If I was to change this into a decimal, the method that I would use is called the calculator method, where I type in 98 and divide it by 86, and then lo and behold, the calculator gives me a decimal. I know, right? Now, this is the decimal that I'm looking at on my calculator is kind of ugly. So I'm only going to put 3 decimal places, okay? I got 1.395, so that 9 would round up to 1, so it's really going to be 4. I missed a number. 1.140 for 3 decimal places, okay? So there we go, 1.140. Now the percent for this one, we would say, well, the hundredths place specifically, which is the 4. The 4 is in the hundredths place right there, right? How many of those hundredths are there? There's 114 of them. So we just look at this kind of as its own number. So that'd be 114%. Boom. So this next one, it gives us the percent, right? Now, if I was doing this by hand, not that I will in the future, but if I was, I'd say I got 0.45%, right? Like this. So how many hundredths is that? It's 0.45 of them. So as a fraction, it would look something like this. But remember, with fractions, we don't really want decimals in those fractions. It just makes math people feel nasty inside. So what would we do? I'd say I'd move this decimal 2 times to the right and this one 2 times to the right and fill in empty spaces with zeros. So now it's 45, what is that, 10,000ths? And from here, I would look to simplify. Both of these are divisible by 5, right? So divided by 5. So that'd be 9 and 2,000ths. As a fraction, anyways. 9 2,000ths. Now, I did the fraction first because, to me, the fraction is more difficult than the decimal. By hand, anyways. If I wanted the decimal on this thing, you just move the decimal from the percent 2 times to the left and fill in any empty spaces with zeros. So this ends up being 0.0045 as a decimal. So if I look at the decimal there, 6.71, and I wanted to change that to a percent, see how I moved the percent decimal 2 times to the left? So for this one, I would move the decimal 2 times to the right, which would then make this 671%. Okay? And actually, that is how I'm going to change this into a fraction now that I have the percent. Not that I would really need to. Because I would say I'd have 671 hundredths if I were to look at the decimal right here, right? The 1 is in the hundredths place. So there'd be 671 of those suckers. Or as a percent, 671 over 100, boom, you got your fraction. And I don't see that 671 could be simplified by any common factors of 100. So there we go. Now, we've seen this before. We can use a calculator if we want to. Okay, now we've seen this before. Of course, with the fractions, you just type it in as a division problem, right? So you'd say like the 1/5 you do 1 divided by 5. You wouldn't use the N over D button on that case because you would want the decimal. At least with the calculators that we use, right? Or what you can do is you can type in 1 divided by 5 like this. You can push equals if you'd like. But what you can also do is you can push the second button. It's that green button in the top left on our calculators. And then if you push this next button, you're telling the calculator that you want to change this, I guess, division into percent. And if you look right above it, it shows like a little arrow, then a percent like this, right above the button. So that's like telling the calculator, hey, I want this as a percent, right? So you do 1 divided by 5, second parentheses, and behold, it changes it into percent. It would work for any of these, right? So if I did 9 divided by 2,000, second parentheses, close parentheses specifically, boom, it gives me 0.45%. Okay, so the calculators that we use in class here will change these into percents for you, which is extraordinarily convenient. Now, let's say that you had a percent, okay, and you wanted to change it to, I don't know, decimal or fraction, okay? So let's go back to, let's do 0.45%, right? So 0.45. So I'm going to type in 0.45 in my calculator, but I want the percent sign, and the calculator will do it for us by pushing this button sequence. You can push the second button, which is that top left green button. And then you're going to type in the open parentheses button, and you can see right above it, it has the percent symbol. So second open parentheses, and you can see on the screen of the calculator, it shows the percent sign. So I push enter, and it changes it into a decimal directly for me as 0.0045. Now, if by chance I wanted that as a fraction, I just push the double arrow button right above the enter button, and it didn't. Stinking jerk. So here's what I'm going to do. No, that didn't work either. Well, I guess I might have to, you'd have to probably change this by hand, the decimal to a fraction at that point. So, but we've done that already. Number 5, you have learned several ways to solve a proportion. Oh, and we loved it so much. Problems involving percents can be solved using the percent proportion. We've seen that, which is used to convert one fraction into an equivalent fraction with a denominator of 100. Write a proportion to help you find the number that is 15% of 40. Okay, in the percent proportion, you see the percent, it just always goes above 100 right there. But in these types of problems, the way they're worded, there's 2 words that are crucial in order to placing the values. And they're very complicated words, words that we may be slightly unfamiliar with or extremely familiar, depends on your background. And this shows the amount over the total. The amount is usually the number associated with the word is. And the total is usually associated with the word of. Is, of. So in case you were wondering, I don't know where to put these numbers. If you can find the word is and the word of, that should help you to figure out where those numbers go, okay? So, if in this one, right, proportional, what number is 15% of 40? So I set up my percent proportion. Okay, now this one tells us the percent, right? Boom, 15%. And the percent always goes above 100. See that right there? So I put it above 100. Not as a decimal, but as a full percent. By dividing it over 100, that would change it to a decimal though. But in the proportion, I want to see 2 fractions. Now, what's the next word we notice? Of. It's of 40, right? See, of, that's the total. So since it's of 40, that number would go in the denominator right up in here.
Then can we just do fish method?
Yeah, because now the is amount is the value we don't know. There's got to be one value we don't know usually, unless it's asking you if they are proportional.
Wait, isn't the x the
So 15 over 100 equals x over 40. And yeah, now this becomes a percent or a proportion, a regular proportion that we can solve. And when we solve it, we will have the amount in this case, okay? Now, I heard someone say fish method, so that's what I'm going to use, even though you don't have to. You could use cross multiplication if you'd like, but you should get the same answer either way. So I would use go down to 40 from x to make the tail of the fish, cross up the 15 up in here. Swing it back down to 100, create the head of the fish, and then it equals x. By the way, fish cheeks taste very good. So then I type this into my calculator, right? 40 times 15 divided by 100, and I get 6. So this unknown value is 6. The answer is 6. Boom, I did it. Now, we have done proportions before, so as long as you can set these up, hopefully solving it is not a big deal. Could you have solved it like a regular equation? Meaning that you could have multiplied both sides by 40 using the principle of equality for multiplication? You could have, and that would have made a phantom 1 there, and then you solve for x. It's the same answer either way. All right, let's go ahead and write and solve proportion for each of these. We got 2 of them up in here. Part A, not part A. So, what percent of 25 is 20? So let's set up our percent proportion, then we'll figure that out, okay? So it says what percent, that means we don't know the percent, right? And the percent goes above 100, and that's my unknown, and I'm just gonna use x for my unknowns on these. And then what do we get? Remember, it's always is over of, right? And they gave us both. It says of 25, so that would be the denominator there, is 20, so that's our numerator. And remember, the wording on that could change. They could say what percent is 20 of 25. It still would set up exactly the same way. Now, at this point, you could use, I would look at this one and say I can use scale factors on this one, because I know 25 times 4, it's a pretty easy one, right? It's a quarter. 25 times 4 is 100. So I would scale up to 20, and that would give me x equals 80. Now, did you have to use scale factors? No, you did not. You could have used cross multiplication. You could have used fish method. I don't really care. But just as long as you get the same answer as I do. Let's think about this a different way, though, okay? Instead of thinking about this in terms of the words is and of, remember that it's part over whole, or what did they say? That was the part over the total on that last slide. So it was the amount over the total, right? So this one, you could ask yourself, 25 and 20, those are the two values they gave us. Which one is the amount and which one is the total? Well, it's always of the total. Again, I guess I'm going back to the word of. But I mean, hopefully you don't have to think about this too deeply to figure out which is which. If I told you something of 25 is 20, we kind of expect you, I mean, just to know the relationship between a total and the way that's worded. Hopefully you know that 25 is the total, and then the part or the amount that was given is the 20. So it's 20 out of 25, which sets up that fraction 20 over 25. In the percent proportion, the 100 is always, it's constant because the percent is always out of 100. So that 100 will always be there if you're setting up the percent proportion like we are here. All right, so let's set up a percent proportion for B. All right, so we got, it's always out of 100. And remember, we got the percent, then it's the is, and the of, right? So is the part or the amount, of is the total or the whole. Part over whole, amount over total, however you want to look at it. Now, we are looking at dollars on this one, but it does ask what percent, right? So just reading the whole thing, $12.75 is what percent of 50 bucks. So again, they're saying, what is the percent? Well, we don't know the percent, which means, again, I would have to use some kind of unknown on this one, which again, for me, I just use X, okay? Because the percent always goes above 100. But then we got to figure out where the 1275 goes and the 50. Now it says it's what percent of 50. It's usually of some kind of total or some kind of whole amount, which again is why we look for the word of. Of 50 would mean that it goes in the denominator here. So there's a 50 right here. Now, it doesn't say is 1275, but you see how it's kind of associated with the word is right there? You don't really have to think about it that way, but just by the process of elimination, we should know then that the 1275, because it is not a percent, has to be the numerator part of the second fraction there. So that'd be 1275. You can label those if you'd like, but the labels are going to cancel out as phantom ones anyways. So we used scale factors and fish method. So I'm going to use cross multiplication on this one. So I do x times 50, which I would just write as 50x, which equals the other cross, 100 times 1275. So that'd be, $12.75. That'd be $12.75 there, which now equals 50x. And then, to solve for x, the unknown, we would divide both sides by 50. Right here. I'm not going to do that in my head. I'm not feeling it right now. I got 2550 on that. 25.5, I should say. Now remember, it's not good enough just to write this, if you're doing it by hand, as 25.5. Because it said what percent, which means we do need some kind of label on this, which of course would be a percent. So the answer to this one, $12.75 is 25.5% of 50 bucks. Done. So number 6, write and solve proportions for each of the following percent per problems, whatever. What number is 5% of 60? C and D. Let's look at C first. What number is 5% of 60? Well, it's a good question. We've got to set up our percent proportion, right? It's always out of 100. And the percent, they did give us a percent on this one. So I know the 5%, that the percent always goes above the 100, and that's 5%. So it's 5 hundredths. It equals, and remember, we're looking for the two words, is and of. And it says, what number is 5%? Just don't get this one mistaken, because some students would say it says is 5%, so the 5 would go right up and count. But it does not go right there, okay, because it's already percent, so we know where the percentages go. It does say of 60, and it's always of the whole or of the total. So I know that would go in the denominator of the second fraction right there, which means that we don't know the part or the amount. And now that we have it like this, we can solve it. And I'm going to use fish method on this one, okay? So 1, 2, 3, 4 values, multiply, divide, equals. Start at the x, go down to 60 to make the fishtail. It's the first number we get. Cross up to the 5, swing it back down to 100, makes the fish head. And then finish off where you started, which should always be at the letter, okay? So x, that's our part, or the amount. And I'll just type this into the calculator. 60 times 5, divided by 100. Boom, 3. So this tells us that x equals 3. So 3 would be 5% of 60. And you can double check this. 3 divided by 60, what does that give us? 0.05, which is also 5%. All right, 12% of 85 is what number? So another percent proportion on this. And once again, they did give us the percent, 12%, which always goes above the 100 in the percent proportion. And again, they give us of some number, which is 85 of 85. In fact, this one's a little bit more direct with the is statement. Is what number, which means we don't know that is statement. So I would have to use the x right there, the unknown. But of 85 should be a little bit more clear as well, because it's the whole. The of tells us the whole or the total. And this is the percent proportion we get, okay? So I used a fish method on that last one. Let's go ahead and use cross multiplication on this one, okay? So I'd have the first cross, 12 times 85, which is 1,020. And it should equal the other cross, which would be 100 times x. Well, at this point, just divide both sides by the coefficient of x, just like you would with a regular equation, 100. And you get x equals 10.2. So 10.2 is 12% of 85. And again, we can check this. 10.2 divided by 85. When I push enter on my calculator, I get 0.12, which is 12%. So 10.2 is the answer. So we're still writing the proportions and solving these, no problem. So the percent proportion, percent out of 100 equals the part over the whole or the amount over the total. And they gave us the percent right away. There's 40% right there, so it goes over 100. The percent always goes above the 100. And the 100 is always there in the bottom left, at least the way that I set them up. And then notice this is 26. The is the numerator of that second fraction. So get a 26 right up and count. The unknown in this case is the total or the whole amount. The whole or the total. And from this point we could, well, I'm going to use fish method to solve it. I like fish method. We have 4 values. Multiply, divide, and equals. So I'd start from the x, go up to the 26, cross down to the 100, bring it back up to 40, and an x. And of course this is nice because I can just type this directly into the calculator. 26 times 100 divided by 40, 65. So 40% of 65 is 26. And you could check this, by the way, right? You could say, well, 26 divided by 65. And when I push enter on my calculator, I should get 40% or 0.4 as a decimal. And I do. So it does check off. All right, you guys take a minute and try F, then we'll go over it. Okay, 1 minute, go. All right, hopefully that was good. You guys had enough time to figure that out. Let's go ahead and put it in. Now, the first thing I always look for on these ones is the percent. Do they give us the percent? Because I know that number always goes above the 100 in the percent proportion, and they do. 75%. So I know it goes above the 100. It's the numerator of that part of the fraction, the proportion. Now it says, of what number? Okay, so there's 2 things. It says, of what number, and it says also 84 is. So I know it's of some number, which means that's something we're looking for. We don't know what it is. And the of number is always in the denominator of that second fraction. The 84 is goes in the numerator here because it's associated with that word is right there. So it's 84 over x, which means it sets up pretty much the same way as that last problem we just did. Okay, so I use fish method on that one. I use cross multiplication on this one. Cross multiplication, 75 times x should equal 100 times 84. That's not a hard calculation, just 8400. And then to solve for x, I would divide both sides by 75, which gives us 1x, right? Just like we would solve a regular equation. So 8400 divided by 75 equals, in my calculator, 112. So 84 is 75% of 112. And again, we could check this, right? 84 divided by 112 equals 0.75, which is 75%. Boom. They're so fun. No. Welcome back. A local bakery sold 60 loaves of bread in one day. If 65% of these were sold in the afternoon, how many loaves were sold in the afternoon?
39.
Oh, hey, whoa. All right, so we got 60 loaves of bread. And yeah, we're going to use the percent proportion for this one. And we're pretending like some of you guys don't know how to do this one. Even though all of you may, but some of you still may not. I don't know. Okay, now they gave us the percent here, right? 65%. Again, that's the first thing I would look for because it's an easy one to put in. The next thing is, these are worded different, right? Because it's a word problem with some loaves of bread. Hopefully they're warm. I like them when they're warm, you know what I'm saying? So you put the butter on it, it just kind of melts right on it. Anyways, they sold 60 loaves of bread. Okay, it's 60 loaves of bread. And so we may have to ask ourselves, is that a part or a whole? Is it an amount or a total? And this one is a total amount of bread that they sold, right? A local bakery sold a total. It doesn't say a total, but we should know that it is a total of 60 loaves of bread in one day. what that means is the 60 is going to be the denominator, right? Because the total amount goes in the denominator of that second fraction, which means the amount that they did sell, which is the 65%, is the unknown value that we're solving for. So I'll use fish method on this one because I like it so much. Not that you have to use fish method. So multiply, divide, and equals. And I would make the fishtail from the x go down to 60, cross up to 65, swing it back down to 100 to make the fish head, and then finish off the fish with x. Now we start with the unknown, make the tail, then the head, and then finish off at the unknown, okay? So in my calculator, 60 times 65 divided by 100 equals, I get 39. Now just keep in mind though, the answer is not actually 39. Okay, and you may wonder, well, why is it not 39? Because it's a word problem.
It's 39 loaves.
Yeah, we need to label it in loaves. They sold 39 loaves in the afternoon. Boom. One. Brand A cereal contains 10 cups of cereal, where brand B claims to have 30% more cereal than brand A. How many more cups of cereal are in brand B cereal? Okay, so let's start with brand A, okay? So brand A, boom, 10 cups. So A is going to give us 10 cups of cereal. Yummy, delicious cereal, okay? And then B, we don't know how many cups there is right now. I mean, some of you guys do, obviously, but some of you guys don't, that's fine. It's just that it's 30% more cereal, right? So there's a couple ways to set this up. So brand B, we need to figure out how many cups are in there. And we can do that with a percent proportion because they said it's 30% more, right? So I'd say brand B has 30% more. So I just need to figure out 30% of the 10 cups, which is how many cups are in brand A cereal. So that's a 30%. That's why I got it over 100 right there. It's 30% of the 10 cups from brand A cereal. So the 30%, that's going to tell us how many more cups are in brand B. Now, some of you guys may be thinking, well, I used 130%, and that would work. It's just going to tell you the total amount right away, right? And yeah, for some of you guys already know it's 13. That's fine. Now, however you solve this, doesn't really matter. Fish method, cross multiplication. I use cross multiplication now. So 300 equals 100x. Divide both sides by 100. And you get x equals 3, right? So this is 3. So 30% more means it's 3 cups more cereal. Or if they wanted the total amount of cups in brand B, which is not the question, it would have been 13 cups, right? I guess I shouldn't circle that in. It's 3 cups more in brand B. But there would have been 10 cups in brand A and 13 cups in brand B. Is 40% of 70 equal to 70% of 40? Could this pattern be true for other numbers? Prove it. Okay. 40% of 70. Let's find out. Okay, so the percent proportion right here. Now we'll do this one in red. It's 40%, right? So the percent goes above 100. It says it's of 70, so we know that goes in the denominator. We'll be solving for the part on this. Okay? And you can solve it any way that you like. I see cross multiplication works pretty good on this one. So 40 times 70 is 2,800. Would equal 100 times x. Divide both sides by the coefficient of x, 100. Just principles of equality, right? Makes that x equals 28. So x would be 28 on this one, right? Okay. So that was that first one. But is this equal? 40% of 70 is 28. Is this 28 right here, is it equal to 70% of 40? Let's find out. So set up your percent proportion. It tells us the percent on this one, which is 70. It says it's of 40 right here, so we'll be solving for the part again. And whatever that is, we're going to compare it to 28. If it's equal to, then we'll say, yeah, this is good. Okay, so cross multiplication would work, but you could use fish method if you like. 40 times 70 divided by 100 should equal the x there, and I get x equals 28. So we got this green 28 and the purple 28. Are they equal? Yes. Yes, they are. So I put yes here. Could this pattern be true for other numbers? The answer is yes. Now we should be able to see in the two proportions, all that happened was that we took the 70 and 40 and we just switched them, right? Now with cross multiplication, we can see that you just multiply the 40 and 70 no matter what. So it's not like it's going to make a big difference on that. And, well, I guess we kind of proved it. The positions of those aren't going to matter. Whether you use cross multiplication or fish method, you're always going to be multiplying those two values, and the order of multiplication doesn't matter because it is commutative.